Good morning! Today we will learn about the nature of the roots of a quadratic equation. But before that, let's first have a review on the types of numbers. So a number can be real or not real. Not real numbers are also called imaginary numbers. Now, under real numbers, it can be rational or irrational. Rational numbers are numbers that can be expressed as a quotient of two integers. Some examples are fractions, integers, whole numbers, and natural numbers. While irrational numbers are numbers that cannot be expressed as a quotient of two integers. Some examples are the square root of non-perfect squares, non-terminating and non-repeating decimals. For not real or imaginary numbers, examples of which are roots of negative numbers. Say for example, square root of negative 5, square root of negative 11, and so on. The table shows some examples of real numbers and not real numbers. So under real numbers, we have square root of 81, 1/8, square root of 11 over 4, square root of 20, 7 over 12, square root of 5, 22, 116, and 3.75. For not real numbers, we have square root of negative 9, square root of negative 36 over 16. Let us now proceed into discussing about discriminant and nature of the roots of quadratic equation. The value of the expression b squared minus 4ac is called the discriminant of the quadratic equation ax squared plus bx plus c is equal to 0. Now this value can be used to describe the nature of the roots of a quadratic equation. It can be 0, positive and perfect square, positive but not perfect square, or negative. If the discriminant is equal to 0, then the roots of the equation are real, rational, and equal. If the discriminant is greater than 0 and the perfect square, then the roots of the equation are real, rational, and unequal. If the discriminant is greater than 0 but not a perfect square, then the roots of the equation are real, irrational, and unequal. But if the discriminant is less than 0 or a negative number, then the roots of the quadratic equation are imaginary or not real. Okay, so let's have some examples. Number 1. Describe the roots of x squared minus 6x plus 9 is equal to 0. First, we need to identify the values of a, b, c in the given quadratic equation. So in the given equation, a is equal to 1, b is equal to negative 6, and c is equal to 9. Next, we substitute these values in the discriminant, which is given by b squared minus 4ac. b is negative 6 raised to the second power minus 4 times the value of a, which is 1, times the value of c, which is 9. Next, let's simplify. Negative 6 raised to the second power is equal to 36. Negative 4 times 1 is negative 4. Times 9, we have negative 36. 36 minus 36 is equal to 0. Therefore, the value of the discriminant is 0. Now, since the discriminant is equal to 0, then we can say that the roots of the given quadratic equation are real, rational, and equal. Next example. Determine the nature of the roots of x squared plus 8x plus 15 is equal to 0. So in the given quadratic equation, a is equal to 1, b is equal to 8, and c is equal to 15. Let us substitute these values in the discriminant b squared minus 4ac. So b, we have 8 raised to the second power minus 4 times the value of a, which is 1, times the value of c, which is 15. 8 squared is equal to 64. Negative 4 times 1 is negative 4, times 15 is negative 60. 64 minus 60 is equal to 4. This now is the value of the discriminant of the given quadratic equation. 4 is greater than 0 and at the same time it is a perfect square. If the discriminant is greater than 0 and a perfect square, we can say that the nature of the roots of the equation are real, rational, and not equal. Third example, describe the roots of x squared minus 8x plus 13 is equal to 0. In the given quadratic equation, a is equal to 1, b is equal to negative 8, and c is equal to 13. Let us substitute these values in b squared minus 4ac. So for b, we have negative 8 raised to the second power minus 4 times the value of a, which is 1, times the value of c, which is 13. Negative 8 squared is equal to 64. Negative 4 times 1 is equal to negative 4. Negative 4 times 13 is equal to negative 52. Now, 64 minus 52 is equal to 12. 12 now is the value of the discriminant of the given quadratic equation. Now, 12 is greater than 0 and it is not a perfect square. So since the discriminant is greater than 0 and not a perfect square, therefore we can say that the nature of the roots of the equation are real, irrational, and not equal. Another example, determine the nature of the roots of x squared plus 5x plus 7 is equal to 0. In the given quadratic equation, a is equal to 1, b is equal to 5, and c is equal to 7. Let us substitute ABC in b squared minus 4ac, or in the discriminant. For b, we have 5 raised to the second power minus 4 times a, which is 1, times c, which is 7. 5 squared is equal to 25. Negative 4 times 1 is negative 4. Times 7, we have negative 28. 25 minus 28 is equal to negative 3. So the discriminant is equal to negative 3. Since the discriminant is less than 0 or a negative number, then we can say that the roots of the equation are imaginary or not real. So that is how we identify the nature of roots of a given quadratic equation. Thank you very much.